Welcome at our series of FJelinek lectures in Prague. So, and it's a great pleasure for me that I can introduce Professor James Pustiovsky as I don't know, 7th speaker of the approximately, I'm not sure, of FJelinek. Pardon? No, this lecture series. As you know, Professor James Pustiovsky is TJX Feldberg Chair of Computer Science at the Brandeis University in Massachusetts. He is the director of the Laboratory for Linguistics and Computation at the Brandeis University. You all know that he conducted a research in lexical semantics, artificial intelligence. He's interested in temporal and spatial reasoning, in corpus linguistics and language annotation. I would like to mention only the very few projects which have the very high impact on the research community. Is the Generative Lexicon, that means the theory of linguistic semantics, which focuses on the distributionality, the distributed compositionality of the language. The second important topic is concerns spatial and time relations, and he is one of the prominent authors of the project of time ML. That means the markup language for denoting temporal and spatial event expressions. And he also participates in a project which he directed the efforts to create a ISO standard for expressive specification of representing of spatial and temporal relations. He is an author of many important books. I would like to mention mainly the Generative Lexicon, and he is also involved in teaching at Brandeis University, and he is the chair both of the program in linguistics and language and computational linguistics at Prague. And now he will talk about representing spatial information in language.
Thank you for those kind words. Thanks for the opportunity to speak here, and I appreciate the invitation to give this lecture in the name of dear colleague Fred. I will be talking about mostly the theoretical foundation for some of the applied work that I do with my group and with colleagues. And in conversations with a few of you before the talk, there was interest in sort of exercising the more computational and annotation-based work that I've done. I'm happy to talk about that during the discussion period as it relates to the theory, or subsequently later today or tomorrow if you're interested in that. What I want to talk about today is modeling, coming up with the right representations for space so that we can use the representations for not just theoretical linguistic modeling purposes, but also for computational end and computational gains. So I'm going to talk about 3 things. Let me just get the bullets here. I'm going to talk about the notion of function, and that'll be the closest to the semantic representations from Generative Lexicon and that information that's encodable and encoded in the Qualia structure with the notion of the Telic, or the purpose of objects and actions, and why that's important for modeling space. I'm going to talk about a little bit on the compositional nature of that, which is just very brief, just kind of reviewing how some of that information gets incorporated into the grammar through coercion. But I'll move quickly to the dynamic interpretation of qualia and event structure that's, I believe, needed to situate lexical semantics into a dynamic compositional framework that actually provides for a true dynamic semantics and not just what I consider from a lot of the work that's done just a variable assignment change semantics, and I'll make that clear. That model, this employing a hybrid logic of dynamic logic and interval logic, will be used to drive a number of applications, including mapping to a Google KML representation, as well as other types of interfaces to other modalities. That got me interested in other ways of using the representations from GL, Generative Lexicon, and lexical semantic representations for perhaps other types of useful or practical applications as they've been explored in the spatial community. So both in cognitive science, dealing with vision and space, as well as GIS, geographic information systems, and geography and archaeological, in architectural studies, there's a distinction made between place and space, and I wanted to see if there was a way of formally representing this distinction using some of the notions of qualia. And there is not. Just using qualia by itself, you need to have a dynamic notion of action as well. So what happens is that by using the qualia and this new notion of dynamic interpretations of events, you can arrive at something which allows you to model affordances in a kind of ecological perspective, to use a Gibsonian term of the affordance space of an object. And I call that teleotopology. And then I'll have some initial results of some mappings from a logical representation in dynamic interval temporal logic through a simulation construction and then output into a Cinema 4D display in a simulation software. Okay. That's a lot, and if I might zip through some slides when I see people kind of getting sleepy. So we'll start off with just some basics, as we say in English, mom and apple pie. This is basically, everybody knows this and probably agrees with it. So spatial prepositions and particles are the chief ways of expressing spatial relationships if they're not verbal in nature. So verbs and spatial prepositions are the predominant drivers for expressing the key or the trigger for a relationship between two objects. So there's two types of position and two types of verb types. Verbs expressing movement, position, translocation, translation, and these have to be distinguished. So one is just an object moving across space in presumably a random fashion or perhaps a path in a directed fashion. And then, of course, there's postural movements involving the transformation of the object relative to perhaps to some orientation or just a deformation. And these can be modeled in 2 and 3D space with various types of topological calculi. And I'll talk about them in a limited fashion as they relate to language. We all know about attributes that relate to space. Their attribute domain is usually taken to be the domain over which we would distinguish values over some kind of scalar modification. For many of these, the scalar is just ordinal and not necessarily rational or integral or anything else stronger. Spatial nominals are going to be actual ways of referring denotationally to a space, either logically, such as a corner or a volume, or something where I've lexicalized in the language something which does something similar and perhaps even specialized. Perhaps even specialized in that it's actually encoding function as well. So the distinction between a chair and a seat. And then, of course, languages that either exploit through just free lexemes, such as river. We know what rivers denote. But languages that actually use classifiers to take a river shape and apply it to essentially coerce the interpretation or take a codomain of an object. So a table can be referred to in its dimensional form. The classifier system such as this would take table river as a classifier to mean the extent of the table as opposed to table some other classifier. So those are strategies. For selection purposes, there's a couple of things that we need to consider when trying to think about things compositionally. Positional and posture verbs are themselves denoting spatial configurations in the world, or transformations over spatial configurations in the world. Other verbs select space, select locations. Filling refers to something requiring a container. Wipe refers to surfaces. Cover takes some kind of extended object and then does essentially the obfuscation of it. And leave requires a region, enter, so on and so forth. So there's a coercion actually going on here, or some sort of what I would call subselection coercion, where I take a table, and I don't need the whole table in order to understand wipe the table. Wipe is only going to essentially exploit the surface of the table. That's all that's required, because that's all that wipe cares about. So erase the whiteboard does a similar thing. The whiteboard is this artifact that erase is only interested in the content of the surface, and so on and so forth. Interestingly, coercion is all over the place. I'm not going to talk about coercion to any extent, but room is a spatial denoting DP, and enter will be said to select and match the type of room specified, but there's no matching here because a party is an event, and there's a mismatch. So that mismatch has to be accommodated through some sort of coercion, wherein I essentially have to find the location for the event that's mentioned here. So this is a minor coercion, but it's actually critical if you have a strict typing system. And I've written about that with Anna Rumshisky and Nicholas Asher. So let's look at a real data that I'd like to analyze and find some kind of interpretation of. This is a very nice example that we've been annotating over travel blogs that are for biking, from a biking group. They go from essentially, I think, Canada, maybe even Alaska, all the way down to Tierra del Fuego. And they basically blog about their incidents. And this is the segment taken from Central America. And we've annotated this data for temporal information as well as for spatial information. And what comes out very clearly here is a very nice distinction between path and manner verbs, and then all that entails. So the reds, I don't know why the reds are reds. I think I got the color screwed up. Yeah, I did get the color screwed up. Sorry. But you can just read it, okay? Now the greens, okay, the greens work. They're locations. They're places, okay? Agua Azul, and is not a location. And so on and so forth. Waterfalls. Oh my God, the colors got screwed up. Did you get the idea? Now, what I want to do is essentially to come up with some kind of parsing, semantic interpretation, then essentially a simulation of this so that I could do a number of things. One, convert this to the projection onto a Google map or some kind of KML consistent, compliant representation. Certainly not to find the local Starbucks in Ocosingo, but something, like that, right? But I'm interested in doing it from a semantic interpretation, not just from a kind of a hack. Okay, now that involves looking at the distinction between path and manner verbs in some depth. So what I've been working on over the last couple years with Jess Moskowitz, a PhD student who has since graduated, as well as Inderjeet Mani, is to find this way of language encoding movement and to then try to formalize it into an operational semantics that we can then do a number of things with. Create a model, create a simulation, which I take to be a temporally traced model from a viewpoint. It's still a formal device. Or actually then link it to other interfaces. Perhaps an image, a set of constraints coming from a spatial database, or perhaps a map, okay? Or maybe just talk about it in a sort of a natural language generation verbose way. So several things are important that are just facts, right? Language has path and manner constructions. Some languages, some linguists like to make the point that there's this strict either-or. So this, typically coming from a strict Chomskyan tradition, you'll see languages are either path or manner, or you have manner or goal. And I don't buy this. I think the data speak for themselves. and just come up with the generalizations on the basis of the data. That's my take. There are certainly strategies, and we're going to look at the strategies. The strategies are, for example, that a language like English employs both manner construction patterns and path construction patterns. So a path, I'm going to make a formal distinction that a path is a change with a distinguished location in mind. And distinguished location is a formal term that we're going to use in the logic. Manner has no distinguished locations whatsoever. It's just going to be basically an assignment verb, just changing the value of something and just running with it. But they can compose. So indicators of paths: arrive, leave, exit, and then the other particles: to, up, towards, from. Manner of motion verbs, well, they're a lot more numerous. And if you take Levine seriously, then that's the beginning, and then he just keeps going and going and going. And the off the page is intentional because they're essentially everything else, right? So it's clearly easier to find the lexically encoded path verbs and then basically assume as an elsewhere condition everything else, if it's motion, is just going to be manner. All right. Well, what kind of topological relationships are there, and how much can topology get us? Because not everything's topology, right? You've got topology orientation. You've got metric values. So topology alone only gets us arrive, leave, exit, and land and take off. And land and take off are not orientational, because a fly can land on the ceiling, okay? So it doesn't mean that you're going up. So land just means to basically to come on into contact with. And the fly can take off from the ceiling too. So orientation, when you impose orientation, you get climb and descend, things like that. Adding metric values, you're going to get the change of a value of a proximity or inverse proximity. And then, of course, you can put them all together, and you get a verb like hover, which I don't have listed, or expressions such as just below, just above. We have to model these. So the data, I'm not going to go into the details of the data. You can find at least 3,500 articles in linguistics to talk about this. And I'm sure you're familiar with them. So you have something like arrive, and the path, manner verbs are like walk and run, and the classic Jack and Doff, waltz out the room, things like that. Path verbs, path construction languages, they encode the change, the radical shift in the location, such as descend, by the verb, and then the adjunct gives you the manner. So the classic translation of the Spanish, descend the stairs walking, that kind of example. Okay. So now, at the same time, let's think a little bit about function, because this is not just about manner and motion. I want to talk about function. And I'm going to do this probably quicker than I'm doing it at the current pace, because we'll be here I'll be here all day. You'll be gone. So selection of function can be done through certain types of prepositions. The important thing to note is that it's not just selecting for a location. It's imposing or selecting or something about the functionality of the object. You can have something which is itself referentially functional, such as a seat. So one of you can be in a chair, and there's one person per chair, but two children might be seated in one chair. So there's a function of essentially providing a seat for someone in one structural chair. So function essentially is a dependent on a number of things. Home is where you hang your hat, right? Home doesn't have to be any particular place. The office can be your home for the first, for the last 6 months of writing your dissertation, for example. So, inherent. These essentially evoke function. I would say that the telic role is associated with the function. But they don't denote functions. A chair is an object. It doesn't denote a function. It calls up in a modal context the utility of a chair. Similarly for all these. A house could be used as a chair by a very large troll or something in Lord of the Rings. So adjunction is always available. I'm doing something in order to, or this rock is for throwing at you if you don't like my talk or something. Now, there are constructions that allow distinctions. There's quite a bit of linguistic variability that can be noted, and the thing to note is that there's some consistency. It's not just semi-productive. It's actually quite productive. I can have objects on my bed, but only someone who seems to prototypically be a user, an agent of my bed for its prototypical function can be in the bed in English. My cat can't be in my bed. Similarly, at the blackboard, I can be at a blackboard, but my dog, Jocko, cannot be at the blackboard. He can be near it because there's no potential utility of the function of the blackboard by my rather intelligent poodle, but he's still not that intelligent. So so what's going on here is spatiality as well as the imposed functionality. And similarly, there's all these other relationships, and they exist with prepositional variation in other languages as well. There's also an interesting involvement and more involvement, a degree of involvement with the types of prepositions that you have with events. So this essentially means that Mary and Zach are meeting. It doesn't mean that they're the only ones meeting, but they're at least meeting. And Mary is at a party. Bill is going to a concert. But if I say Bill is in a concert, he's not just going to the concert. He's performing. So, yeah, and you also don't say Mary is in a party. So Zach is in a meeting. Zach is at a meeting. I don't know the variation and the meaning of that, but there's clearly some distinctions of that. We have to account for that somehow. All right, now let's talk about what do we have available as tools to begin our discussion about space. And I'll go through this rather quickly. The only people that you might recognize from linguistic connections, maybe Anthony, Galton, but certainly Nicholas and Laure and Sablerot with their work on spatial prepositions, Asher and View, very important early work on myriotopology, and then Philippe Muller. All the others are basically spatial calculi and spatial addition people. Just as an example, there are a lot of different models. I'm just going to use something called the region connection calculus. And it's a good place to kind of just ground ourselves. So we have essentially one connection of connected, one relationship of connectedness, which essentially is Whitehead's original relationship from like 1932. And you build everything up in terms of that. So you got overlap, and basically you get these relationships. Okay? So if I want to talk about the relationship of the lamp relative to the people underneath it, fortunately it's disconnected. And if it's EC, that would be like the projector on the table. Overlapping, we don't have any real overlapping here in terms of the two-dimensional space here. That would be like a bubble on the inside of a glass. And the inverse of that would be like one of those teas that has little bubbles, a Japanese tea you can drink, something floating inside, and so on and so forth. And then the final one is EQ. Now, are these good enough to model language data? Well, to a certain extent, but there's a weakness. You get in touch, you get contact, but you get a lot of problems. You can't distinguish, as I mentioned before, or as I'll mention here, the orientation of a glass on the table, the smoke alarm is on the ceiling, picture is on the wall. There's commonalities of EC, but there's a lot more going on that the on is telling you. And that's just one very simple example. Then you have examples that really don't have anything, blue paint on the table. You'll have a stain on my shirt. What is that? That's kind of a myriotopological relationship. Right? It's actually in the shirt, not on the shirt. Okay. Now, in order to start bridging or merging these two factors together, I need just to review really quickly what Qualia provide as a way of encoding functional information. So the idea for Qualia comes from the idea that there are hidden events and hidden properties in the lexical representations associated with nouns denoting objects. That's the way it starts. But you can do it for anything, adjectives, verbs, actually even quantifiers. But I'm going to just talk about nouns for now. So you get all these relationships, what something's for, and they show up, and we can kind of typify them, right? And I don't have to read these. You can actually read them yourself. But you know that a cake is eating because a cake is a food, and a car is a vehicle, and a table is a certain type of piece of furniture for whatever. And we've done this classification, and it has consequences. The consequences are that they provide interpretations when the language is lacking and it's a little bit too economical in its signal. So the signal comes in, and there's a lot of call it economy, and I need to essentially embellish the interpretations. And that's where the qualia and coercion come together to give us richer interpretations. Well, this is all kind of probably not new to you, but that's one phase of the representational mechanisms that we're going to need to talk about a new type of spatial system called teleotopology, which is defining the spaces associated with actions. Now, the other thing we need is a treatment of action that allows us to reify these objects. And that's something that for which we need to go outside of the normal realm of an interval temporal logic and bring in aspects of creating changes and assignments to values of objects, of variables, as well as bringing into existence new things. So a dynamic logic needs to be introduced to this, and you need to put them together. So you have a hybrid modal logic, which has a temporal component and a dynamic logic associated with it, and it's a first-order representation. Okay, so to start things off that I'm going to model, we'll go back to the idea of path versus manner verbs, and I'll take as a starting assumption Talmy's consolidation of what's really at the core. What are the frame elements or the schema associated with motion, according to Talmy? And this for him is it's a universal. Okay. Well, the event, the object, which is the mover, the figure, the region or the path traversed through the motion, and then there's this distinguished point of the region and the path, which is the ground. And then there's the manner in which the location is carried out. So variable, quite variable. And then the medium. So is it water? Is it air? Is it maybe a piece of wood that some sort of beetle is boring through and destroying the foundation of your house or something like that? The variability I mentioned before, language to language, which essentially alludes to the constructional library, the different ways of actually building sentences, will now be shown at work. So I have a manner verb, such as biking, and essentially it selects for a figure, John, the mover, and that essentially is a process. It has no unbounded aspect to it. I can reference the starting point that John started moving from, and that's interesting because it has two interpretations. You can depart Boston for 30 minutes, where you're actually talking about the extended process that results from the departing, excuse me, I'm sorry. Depart essentially is a path verb. I thought this was, wait, didn't I have bike? Yeah, I did have bike. Depart is a transitive verb, a transitional verb, sorry. This essentially is a path, and this is the initiation of the path, and this is something which happens in time, usually indicatable at a particular moment, so at 5 o'clock, for example, which indicates that at 4:59 he was still in Boston, and that's considered the ground. I can take a manner verb such as bike and create a point of termination. So this is the compositional interpretation of the to the store acting as a function, an event function, essentially creating really a path. This is a derived path verb interpretation. And I can also add manner information to the one I had before, the path verb, by having some kind of coercion over car to be essentially a driving. Okay, so that's actually a process. So by car, this construction actually denotes a set of events, a set of process events, as it were. Okay, you'll see why this is interesting. Here are some examples. So climbing is something which gives some difficulty because I can climb as a process for 15 minutes. Similarly, presumably falling 100 meters is the maximum fall that Nicholas had, so it's probably a mass determination there. And there's an action bringing about an iterated non-distinguished change of location. And this is what the figure undergoes is non-distinguished change of location. Now what I'm going to say is that the figure creates a path by virtue of the motion. And the action is performed in a certain manner. This is my first reinterpretation of telling. The path is oriented in an identified or distinguished way. Okay? This is going to be just the first informal way of trying to make this distinction. And one more set of verbs I wanted to talk about is the pure path manner predicates, manner path predicates, which allow for both types of conjunctions. Climb to the summit and climb the mountain, where you have different types of syntax associated with them. And that's essentially glossed, as it were, as a climbing with an activity where the to the summit provides for a path interpretation, while this, the path, is actually selected, and in fact, to climb the mountain has a couple of interpretations. One which still allows for the internal motion space, which can be climb the mountain for 20 hours, versus to actually have a successful accomplishment wherein I've essentially introduced by coercion some sort of end of path there. So those are both things that need to be considered. Now, how do we do some of this and then interface it to something that kind of validates our model? I'm going to start with defining the notion of a path. So the path is going to designate a distinguished value from one state to another. And the point that we're going to introduce that's rather new to the way you would think about things semantically, but not programmatically, is that the change in value is tested. A manner of motion verb iterates a change in location from state to state. So this is just a simple assignment and reassignment from a kind of program, semantics of a program. Now, starting off with the kind of a classic event structure that, for example, I had in 91 and 95, something like events go to one of three types, and then states are this, and processes are the sequence of events, which are not really defined, except it's atomic, and transition is a state-to-state operation of some sort, or you can have an accomplishment with a process state. Okay, it works for a large class of linguistic data, but it doesn't account for example, incremental theme. It doesn't actually account for what's going on in the development and the unfolding of an action to create a different type of event. So as a result of that, I've reinterpreted this in terms of a linear temporal logic, where I have states are basically one little cell. A transition is two cells. It's a binary cell. So from phi to not phi. A process essentially is going to be a reassignment of some value in a scale, and that I'll talk about, basically the clean star. And then a derived transition, such as an accomplishment, is actually a complex event structure combining a couple of things, namely a process and a primitive transition. And I'll explain that. So real quickly, I'm showing 33 minutes. I have like 50 minutes, you said? Is that correct? Okay. So let's say that a state is a single frame structure, and within that a proposition is interpreted at the index. I can concatenate that, so I can be asleep at some time, I can be asleep for some interval. I define a transition as a sequence, so this is going to be die, or open a door. And I can do the logical combination of having a door shut for a long time and then automatically opening it, or vice versa. So I can compose extended transitions. Now, I can put that together to make a logic using comps operators of next, there is, for all, and until. And this basically gives me a way of tracking the behavior of the contents of a state relative to where I am now. So this is going to be now. This is going to be the next state's going to have some property phi. This is going to be there is some state, and for all states. So once you're dead, you're going to stay dead. And this is going to be phi until psi comes along, and so on and so forth. So now that's the one component that we need to keep track of where we are temporally in my universe, in my model. But that doesn't do everything, because actually I want to change the world. I don't just want to talk about what happened from state to state. In order to do that, we need a dynamic logic, which is a process logic, basically telling me to do A before B. But it doesn't tell you how long A or B takes, or how long A or B lasts. And it also says to do A while phi is holding. Okay? It doesn't tell you how long phi is going to hold. So dynamic logics are inherently atemporal. They just tell you, like recipes, go grow wheat, make dough, put in oven, right? That's a very simple recipe for making bread, but it doesn't tell you about how long it's going to take to do anything. So atomic programs exist as the base form. You're going to have any number of sets of those. They can be concatenated, which is a sequential operation. You can take the complex forms, so it's like a non-terminal, like a VP and an NP, for example. And then you have this important operation from a proposition to a program. So this is a proposition that says, I'm happy, and this is a test that says, are you happy? So in the logic that I'm talking about, you have propositions, which are formulas, and you've got programs, which are formula-to-formula operations. And you have this ability to change one to the other. So I can change propositions to programs and programs to propositions. You have clean star. This is basically, now the modal aspect of it basically says, every time I do A, I'm going to get the result phi. Okay? Now this is where things are going to start getting interesting. Where, actually I've taken a program which is, every time, so do alpha every time. Okay, so every doing of alpha, or every doing of A. And so this is programs can be put into these modal brackets. And essentially it's just like a modal operator in a simple classic modal logic such as, K or S4. But you've broken it up, and instead of the one simple accessibility relationship, R, from world to world, you've broken it and you've labeled them. So it's like a label transition system. You've labeled the transitions between worlds with programs. So every time I go from this world and I fall asleep, then I'll be asleep. Every time I go from this world and I eat an ice cream, I'll be happy, and so on and so forth. Okay? So those are programs. And that's just the universal, and that's the dual is the existential. Why are these important? They're important because they're going to tell us how to keep track of what we need to do in order to model the internal dynamics of an unfolding program, which is I'm going to take to be the basic way of looking at language semantics. Now, here's a basic program for motion. Manner of motion verbs introduce an assignment. So let there be some assignment, and then I'm going to give it the value z. Okay? So x is the object that has a location, y, and I'm going to give y the location z. And then I'm going to direct it by essentially finding a beginning point, and then I'm going to basically find some. So here's the beginning point of my motion. I'm just going to continue like this. So it'll work for linear structures, but it won't work for shapes that violate that, such as going around a building or going around a lake, because you're not going to, that's not going to continue being directed relative to the begin point. But we can solve that. Path verbs introduce pairs of tests. So, am I not happy? I'm going to just continue doing something until I'm happy is true. Okay? And that, by the way, is going to be the way we're going to talk about all achievements and accomplishments. They're all going to be tests. Okay. So, from this you can build larger structures that I'm not going to get into. And you can do it for any attribute. So you change an attribute. I'm not going to get to the semantics of this right now. But the important thing about this, basically, as I move along, I'm creating something. So all assignment, reassignment predicates are creation verbs. I'm creating a trail. So just as you walk in the snow in the winter, there's a tangibly visible trail. Any action you have, the motion of my hand, presumably speaking, but we're not going to talk about abstract predicates now. Walking, these all create paths. And those paths are objects that I want to reify and then use. Okay? Those are the intangibles that are very much like a lot of these hidden predicates in verbs that people look at, such as translate a Bible. The translation is not selected by the verb, but it certainly exists in the world. Okay? Walking to Boston from New York, the very long walk. That path is something that's created by that, and I want to reify it. Here's just the program structure for the two. I want to get moving because I'm taking too long. And just how this all works in terms of the data that I showed before. Directed motion basically imposes that there is this one direction. I wanted to show one thing that can help elucidate one aspect of manner, and then we're going to talk about another aspect of manner. That essentially topology can construct troponymic relationships between a motion all by itself for some verbs, but not for all. So what's interesting is to think about the troponymic relationship between any particular hypernym as variable dependent on the dimension of subtyping. And so if something is defined or definable in topological terms relative to its arguments, then if you can further define the topological constraints relative to that argument, then those are purely topological subtypes. So, for example, placement of a region relative to each other, the relative topological relation throughout the process, perhaps a myriad-topological relationship. Does everything touch or not touch? And then maybe the medium. I'll give you an example. So slide and hop are toponymic movements of move. And here's how we might model this over a dynamic, this is just a three-state model, but basically I'm just going to continue the contact with it as opposed to that non-contact over some interval. Now, myriad topological relationships basically forces the interpretation of translation. So I'm rotating the object. Okay, so you see what's going on. These are purely topological constraints. This a way of then identifying. The importance of this is that I've identified the Beth-Levine and Malka-Rappaport do X while hammering. Well, what the hell does hammering mean? I've actually created a kind of operational semantics as to what that means so that then I can explore the range of actions possible for that. It's a way of exploring the semantics in a operational way. Okay, I'm going to ignore this and get to some more data. This is the path that would be left by simple motion. Now, the reason this is important, again, let me please iterate and reiterate, is that this path is quantified over. Rather than having an abstract Davidsonian variable E that takes all the properties that seem to be there, location and length and other types of sentiment and emotive adjectives, in some cases, there's actually something created that will take the place of the modification by E, namely of E. I've got a rolling. The rolling is bringing about a path, and that path has a quantification. There's a biking, and it has a length, as opposed to saying that the event is 5 miles, or the rolling is 20 feet, which should be a typing error in your semantics. And it is. So, okay, now moving on, let's get to how this works for just one little thing about scalars. It's the same thing with writing. Eventually, I'm going to get to a point. This is the thing that I'm writing. I'm just continuing to write, and I'm treating it monotonically. This doesn't treat that I might erase a page or throw away a whole chapter or something like that. Don't worry about that. I'm just trying to idealize the creation of an object. And now let me just kind of tell you how this works. There's a shift in a scale. So creation predicates, now here's the complex event that I was talking about. There's a process is a continuous assignment, reassignment. But at some point, it may be the case, and obviously some verbs encode that intentionally, like build, it's going to satisfy my blueprint that I had in mind. So I'm continuing to do something, and all of a sudden, yes, that's what I wanted. Or that's the house I built by spec. Maybe it's not a very pretty house, but it's the house that I built. So that's a shift from the ordinal scale to a nominal scale. The nominal scale now says, oh, you're the house I designed. Let's see how that works. So this is the parallel structure. So this is my complex event structure. I'm building. Eventually, it satisfies the conditions of being that house that I spec'd. Okay? So here's just a simple movie example of building a table. The point is, through the trace allows me essentially to keep track of what I have. So the progressive paradox, right, the imperfective paradox, has a value, but not necessarily the house that I want. Okay. Now, what does this have to do with anything? Well, I'm trying to talk about motion, then function together to create this new type of space called teleological topology. Now, I've been working with a group to make a standard for spatial markup that uses this underlying representation to then map to KML. And I'm not going to go through the details of this. It's going to model the following types of attributes in language, not just the stuff I've talked about, but frames of reference, spatial attributes and nominals, measurements. And let's go back to this text. And I'm going to go through this text now. So here's the text of David leaving. Leaving is a path. Arrive is a path. Bike is a manner. In a construction to create a path. Play is just an internal movement, just a process. Spend is also just a continue to be, that's actually kind of a non-movement verb. And then drive. Drive to is a path. So essentially, just schematically what's going on here is that we identify the events and the times, the locations, essentially come up with some underdetermined constraint structure, and then with the semantics of the predicates of what leave the dynamic interpretations of all these, we map essentially to create the following types of dynamic root. So leaving essentially doesn't create an orientation, but it's essentially constrained by the discourse with the next sentence, and the next process gives rise to a path constructed predicate to the next one, and interestingly, kind of a bridge case through some inference, and so on and so forth. And that's how that kind of mapping to KML works from the semantics. So my interest is in how plausible is it? How real is it to go from the logic through the annotation representation to then mapping to KML, or to any kind of mapping representation? Now, in the next 5 minutes, I'll do the last component of the paper, of the talk, to talk about this teleotopology. We can identify 3 types of locations: natural, functional, and complex, which interestingly parallels the 3-way classification that Generative Lexicon makes for almost any kind of object in the ontology. Functional locations are like artifacts. Now, the Qualia structure for a chair, and I'm not going to review this, essentially says that a telic, the function of a chair is to sit in it, okay? And it's got this representation of the set of events associated with it interpreted modally. But this isn't strong enough as a modal interpretation, and we need to make it satisfied according to a set of constraints that must be present in order for the telic to work. Now, there's 2 things I want to point out. There's something we can call the function of space, which is the actions associated with a region or an object inherently, such as the telic role. And there's the space of a function, the regions defined by the telic actions performed by an agent, or supervenient on the telic state of an artifact, called the teleotopology, and I'll explain. Now, if you're familiar with Gibsonian ecological perspectives on cognition, there's this quote I have from Gibson talking about this notion of affordance, which people have compared to Qualia structure and the telic role. And I'm basically just kind of taking it and trying to formalize it. It's the idea that that objects have these properties associated with them in our perception, and that helps us classify them in non-standard, non-conventional, typological classificatory ways. So basically, it's how I interact with the object in the environment. And this has been modeled by psychologists and designers for many years. Mark Steedman had an attempt to do this with his own event semantics, and there's quite a bit of work on this. But I'm going to now talk about an affordance, for purposes of our presentation, as a correlation between an agent who acts on an object with a systematic or prototypical effect. And you'll see why this is relevant to what I've been talking about. So, the telic role refers to function and purpose, but there's really 2 levels of modal accessibility. There's a local modality, which is the condition under which the activity can be performed on the object. But there's a global modality, which is what is done with the object and the resulting state, if you do it. So, modeled dynamically, this essentially is a dynamic expression, such as if the context is satisfied, then every time I perform pi, I'm going to get the result r. Okay? Now, this is important because you can say that a beer or whatever, milk or whatever, is for drinking. But you want to specify more than just the activity you do with it, but why you're doing it and what are the results of doing that. And in order to do that, you have to specify what the preconditions are. So this is like a precondition, action, postcondition. Now this can be modeled as this event structure, such that if C holds, then I perform this activity until I've got the result hold and C no longer holds. Now, then we can view a revised interpretation of the telic of sandwich as essentially this modal context of this, like I just said. If the context is right, and then I eat the sandwich, then I'm going to get full, or I'm going to get sated, or whatever. But if I'm already full, or I'm sick, or I've got, some disease, then the result is not going to follow if I eat it, okay? The nice thing about this is that this This is universally quantified so that I don't have to eat it. It's only every time I eat it. Now, let's get to the punchline. A region is created by an action associated with a purposeful action by an agent. And that's very much like what I was talking about, moving and creating a path. A region, another way that something can be teleological is the region required for the performance or satisfaction of an artifact. So in order for us to use a table properly, there has to be enough of a zone above it for me to do whatever I want to do with it. The zone created by my viewing the screen of a computer defines through my joint intersection with the regions here through the orientation. This is going to be a teleotopological area. So, now again, let's go to manner. I've got like 4 minutes of talking. Is that okay? Is that right? Sorry, I'm running a little over. I'm interested in defining Beth's manner type constructions, or the troponymic relationships in WordNet. Okay? So there's cut verbs. But cut verbs are really different. You've got saw, axe, slice, all these others, scissor. And essentially, they're very much like just a basic predicate that you can define constraints for. And in fact, that's the way we're going to treat them. So first I'm going to talk about how to locate an event. Let me forget that one. Let me locate an object. So the location of an object, the spatial extent of that object, is going to be called L. I'm going to have an embedding space for that location. Basically I'm trying to figure out where are you, okay? So you're there, you're defining the extent of your space. Your embedding space is going to be something which essentially surrounds you. Then I want to talk about mu, the minimal embedding space for the object. Okay, it's just going to be the minimal embedding space is going to be the one that I can't find any smaller version of. Now let's take an action. So if I drink like this from the table, then the minimal embedding space for the action from the table is that very action space, is that very region in my domain. The minimal embedding space for that is literally just that trajectory, that arc, okay? So basically what we're going to try to do is constrain actions basically to say, I'm going to do something while phi doesn't hold, then phi is going to hold. And I'm going to try to build up cut like this. And I can add constraints to make more complex event structures. So the first model of an affordance space would be to take the two together, namely the object and the region, and just basically take the two together and make the minimal space that combines them. But that's too weak because I forgot me. I forgot the agent. And the agent is an important contributor to defining the affordance space. So I have to include me in that. So just put me in. Okay, so now I'm in. And now I can go back to saw, the verb saw, and let's now look and see what an operational verbose explanation of this would be. And basically, given some instant of appropriate constraints, such that I have some kind of limb and I've got the hand of y being grasped, so during this constraint, I'm going to push the thing away with a downward pressure until, this is an until constraint, as in the program, and then I'm going to pull. Okay, so I'm pushing and pulling, and then I'm just going to iterate. So basically there's some kind of dynamic interpretation like this, where I'm essentially creating this minimal embedding space. So this is going to be the affordance space, which is going to grow. It's going to have a fixed point because it's not going to necessarily get any bigger, right? While this condition holds, and then all the while grasping. The G is what? Separate, cut in half, whatever. Now let's get to the simulations, and I'll shut up. So the C in these cases that I mentioned constitute part of what I call the habitat. So think of the habitat of an object as the qualia structure on steroids. So the qualia structure gives you a local semantic interpretation. So a narrow interpretation. Habitat gives you a broader interpretation. My interest is in seeing whether or not we can take habitats and actually still find principles of compositionality between habitats, just as we have principles of compositionality and coercion and co-composition with qualia structures and other types of features. So a table can only be used if the top is oriented up, the surface is accessible, right? Has to be available. So the ceiling can't be down this low, for example. A chair has to have certain kind of constraints that are required. The table and chair are spatially consistent. Now notice that once I impose the purpose of the two together, something very interesting happens. That the agent must be able to function at the table from the position in the chair. So I can't have that chair right there and that table and have them be in a consistent affordance space, because I can't do what I'm doing at the table, usually, from that distance. Okay? So there's a kind of set of constraints that are imposed. So now from this, I build a minimal simulation, which is a minimal model from a perspective traced over a dynamic interval. And I'm not going to talk about the details of that. Let's just give some examples. So this is what now we start modeling. This is a minimal simulation, habitat for a table. I've constrained it with putting table and chair compositionally. Now, putting an individual in here, I'm now creating an affordance space that is satisfying the conditions of the ability that I want to impose any particular action at the table is consistent with the placement of the table and the chair. This is unconstrained because there's no table there. Now, the orientation of the individual at the blackboard is also satisfied by virtue of being able to function at the blackboard. So this is satisfied. Now, looking at this dynamically, we take these objects, encode them, and then we compose them, and that creates the first results of the minimal simulations that I have. So here's a sawing. Notice, so I want you to, so the affordance space that's created is the thing that's created by the object. That's the local Telic zone. The affordance space is the entire individual of the region. So I'm interested in just how much space do we really need to identify the event itself. That's an interesting property. Axing takes a very different affordance zone. These are both types of cuttings, right? But notice the affordance zone, the minimal embedding space that's required for axing. Notice that this is kind of not going to be constrained, not going to be satisfied, because so we built it so that it wouldn't be satisfied. The conditions that imposed on what you have to do with a saw with an axe is not going to be imposed. But this would be essentially a kind of silly way of using, and not very effective way of using an axe. Finally, simple door opening. This is a great example of the object, so not just the aperture, which I've always taken to be part of the dot object interpretation of a door, walk through the door, paint the door, but the minimal embedding space for the utility of the door is this entire region that exists by virtue of the extent of the width of the door. Now these are important because I think there's semantics there that is certainly of utility to interfacing to other modalities. For example, I just gave a talk at a cognition conference for the blind. And these types of models for what are you actually encoding cognitively from neuroimaging studies of the space associated with certain kinds of objects. Finally, crossing the street is interesting. This is a full crossing which goes outside of the region, which is very different than, let's say, a boat crossing the river, which of course does not extend outside of the river. So the way you define the internal components of the path versus the external components of the path as being outside of the interior. Okay, let me just shut up now. So language identifies the space used for particular activities and states. I think artifacts can be encoded with information that relates to its purpose, but also the context and space associated with it. I think that regions are first-order objects created in our semantics by activities, and they can be identified as minimal embedding spaces. And this, I think, has consequences for semantic and discourse interpretations. This model of GL that I'm trying to extend, I think, could be interesting to psychologists and cognitive psychologists for how it talks about affordances. And I think that this introduction of a narrow interpretation for our meaning and deep interpretation, qualia habitats respectively, provides a distinct, but they're kind of complementary ways of looking at objects and the events that they participate in. And that's it. Thanks. Sorry, I ran on. I think I went for like 58 minutes. So.
That's perfect. Thank you very much for your interesting presentation. And are there some questions, remarks?
I'm just wondering how to deal with metaphorical movement. Things like this leads to a great pollution, or we are in troubles.
Yep.
Do you consider them to be a normal motion verbs? Or?
Right. So that's a very interesting question. And I don't just say that because I want you to take my answer positively. That's a typical rhetorical move. You know, you praise the person for saying what a fascinating question it is, and you really don't care. I just talked about this. So, well, not with you, but with a different audience. So, the types of motion we annotate in isospace, there's literal interpretation of balloon rising. You've got fictive motion, the tell me fictive motion. So, the mountain rises into the distance. And then there's intrinsic change interpretation of the river rose above the levee, where this is interesting because this is almost kind of any change of state that's changing the value of the intrinsic property of the volume of that object. Metaphorical motion is not in here because we have no idea how to identify it except as the complement of all these. So, but we haven't dealt with the semantics of it yet, except to recognize it as something that is not treated by. So we've intentionally not treated it. Not because I'm not interested in it. I'm very interested in metaphor. It's been very hard to identify. If we can identify these, so here's the strategy. It's the good old Kiparsky elsewhere condition again. If I can identify these, then maybe everything else, keep your fingers crossed, can be treated metaphorically. Now, metaphor, of course, is one person's metaphor is another person's literal meaning. And so, this is something, in fact, for which I've had many days of arguments with Patrick Hanks about. So, trying to determine what the literal meaning of some verb is in the CPA patterns, if you're familiar with those, which I'm sure you are, is a question not necessarily of historical origin, which Patrick will know to excruciating detail, where it was first cited in 825 in Beowulf or something, but all the way to the present. Rather, I think metaphor has to do with the synchrony, the synchronic use of the word in the language. If in fact it's the predominant usage of the sense in the verb, just take a verb, then it's not metaphorical. What does metaphorical mean at that point? There might be some underlying notion of a transfer from domain to domain. It may always be present. In fact, it may be just part of our brains. But I think we have to let the numbers talk. And if something is just as frequent in its occurrence, generally, you have to ask, what's the utility of calling it a metaphor at that point? I mean, you may differ on that. One other sense, not to cut off possible counterexample or rebuttal, but one other sense that we're interested in is very interesting, and it occurs a lot in motion text, which is the route descriptions and like travel guides, walking tours and things like that. It's almost an entire mode of speech. So you get these things that we've annotated with great difficulty, like start at the gate, go 100 meters, take a left at the water, cross over a small wooden bridge, blah, blah, blah. From there you'll see blah, 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 right? And so we were calling these fictive at first, but they're not fictive. Then we were calling them simulated motion, because you're kind of simulating a motion through the thing. And then we realized that it's not simulate, it's not motion. It's almost like a mood, like indicative or whatever. And in fact, some narrativologists, what are they called? They actually treat that as a type of mood. It's a type of discourse. Narrative discourse is essentially not confined to motion. So I can say, imagine that you liked my talk. Now, basically it's a simulation, but it's a type of mood. So I think you're doing something very different, and it shouldn't even be annotated in those cases. But the metaphor, to come back to it, is a true problem that relates to a number of factors, one of which is how does that word actually relate to the other senses, and is it in fact a distinct metaphorical sense? It's a fair question, though.
Thanks for this interesting talk. I have a very vague and high-level question. I think it's 8 years ago when I heard one of your talks on time expressions and time ML. And Back then, I was
Yeah, I'm getting old. It was actually 10 years ago when I started this stuff. Well, no, I don't know when you heard it. I have no idea.
I was very skeptical at what results can we arrive at with this broad aim that you were aiming to back then. And now I'm here because I wanted to see this big aim for places again. So in those years, I haven't followed the development of Timex at all, but I know that last year I just asked one of my students to download one of the Timex tools and tag some text with time expressions and then use them for his application, and it worked for him. So the question is, how far are you with the tools, track and places, and also back to Timex, how far the semantics of Timex is actually used, because all what he used was just the tagging, like named entity recognized for tools, but no interpretation of that. So how far is the interpretation of time expressions, and how long are we to wait for taggers for places? And how long are we to wait for interpretation of places?
Question. And again, I mean that seriously. So Timex expressions, they're actually the best performing Timex system from the last temp eval is the Heidel time from Heidelberg. Actually outperforms our B time at Brandeis. Both of those are fairly good, but as you mentioned, well, Heidel time only gives you the actual value, and it's not going to work on some fairly complex expressions. What I'm working with Martha Palmer and Gergana Savova to do the annotation of a corpus. Well, I think it's actually going to be out. It's for the for one of the biomed competitions. It's for temporal relation. Okay, and so there. You get really interesting, some of the stuff you get in calendars, right? And scheduling. Scheduling intervals, scheduling time expressions, as you know, are much richer and actually quite complicated. So take 200 milligrams of ibuprofen twice a day for the next 10 days. Now, that's a very interesting expression that should be compositionally constructed. Timex2, right, as you know, basically makes that one big expression. It does have it compositionally constructed. It is syntactically compositional, but semantically it's not really clear how to derive it, except unless they're actually using, let's say, a dependency parse with all the interpretations from the syntax, which is good. That's a good thing to do. Other models will treat those as separate Timexes that have to be composed. Now, frequency, quantification, needs to be integrated into the argument structure and the event structure of the sentence. So, for example, Mary taught for 3 hours on Tuesday as a measurement expression. It may be the case that she has 3 one-hour classes, right? And the sum of the teaching is 3 hours. So you need to make sure that you maintain that ambiguity or the underspecification. It's not just one interval that is a convex whole of 3 hours. And then finally, which we do in the TimeML now, although to be fair, the B-time parser doesn't do that. And so again, the spec is not aligned with the tools to do it yet, and that's something we're working on. Quantification, again, is another thing, which is to teach every week this semester, teach every Thursday this semester. You have to make sure that you get the quantifier scope, like any good quantifier raising interpretation would be, so that you don't just get one big event that seems to be linking every Thursday for an entire December, because that's not what it is, right? So for the space, we've been developing the space and place taggers, and they are in fairly initial steps. They're not nearly as rich as they'd like to be. I'd like them to be. The corpus is still being developed for the relations. So the development of the isospace bank is the first release of that probably won't be till like February, but that will be released for. That'll have the spatial prepositions and the QS links, the qualitative spatial links for prepositions and any verb that is actually involved in a spatial link, along with the places. There is a spatial corpus, as you probably know, the holistic spatial semantics, done by the Leuven group, that was in the SEMeval. I have problems with that annotated corpus because I think it's a little bit rushed, and I don't think it's as carefully curated as it should be. So I'm going to try to bring them in and try to re-annotate a lot of that at some point. The goal isn't to win. The goal is to have a good corpus so that we can annotate our algorithms over. So it's not a zero sum. I mean, We really need to kind of coordinate and work together. So that's why we're opening up. The new model for the Tarski toolkit is to have an open architecture for us, so we can basically plug and play other people's taggers or preprocessors or postprocessors or closure algorithms and things like that. Does that answer your question? Yeah.
More questions, comments? So, if not, thank you again very much for your nice...
Thanks for inviting.